What is going on, guys? My name is Hussein, and in this video I want to discuss a question that some of you asked me. When do I shard my database? And short answer for those of you who are impatient, last thing you want to do is the shard your database. There are so many other things that you can do before complicating your life with sharding. So with that said, let's just jump into it. Guys, sharding. The idea of sharding a database is, I know it sounds, the term sounds very sexy, right? So it's like, oh, I'm going to shard my database, and it makes you sound intelligent. But if you think about what you're doing with sharding, it is a very complex architecture and complex operation to implement. So in order to talk about sharding, you have so many other things you can optimize. It's like, why are you doing it to begin with, right? So let's start over. You have a beautiful database. And I'm now talking about mostly relational databases because that's my specialty. I very rarely work with NoSQL databases, but they work similarly. But here's the thing. In relational databases, you have a single instance database, right? And you're probably building a web application, so you need a web server or an API framework such as Node.js, Django, all that jazz, Go application, your custom application, that essentially speaks HTTP protocol that talks to the browsers or some REST clients or any gRPC, not really gRPC, but what is the thing? GraphQL, thank you. Yeah, so GraphQL, anything that's basically HTTP, and you make request, and that request goes to the web server, and the web server makes queries to the database and gets you back responses and kind of change the representation to something that the client understand. Could be JSON, XML, anything, and then ship it back to the client. That's the REST representational, right? Change the representation. All right, so that looks good. What's the problem with this? You get a lot of requests. A lot of people are reading, let's say. It's like, hey, give me all this employees table, or I'm reading this profile, I'm reading this form, I'm reading this tweet, I'm reading this thing. So you're hitting that database a lot. When you're reading a lot, you say, okay, that you're reading from a table, right? And that table is large. It's getting large because you're inserting a lot of stuff in it. It has 1 million, 2 million, 3 million, 4 million, 20, 40, 100 million rows in it. And you might say, Hussein, doesn't matter because I have an index on it, and that index is going to be smaller, right? And I'm going to hit the index because I'm smart. I am going to index the fields, and I'm only querying based on those fields that are indexed. So my queries are fast. But the index can get you only so far, because the larger the table gets, the larger the index gets, and almost you're doing and full index scan, which can also be slow. So the solution is not to just split everything into multiple servers. You're over-engineering too early, and that's what the problem with most people are, just over-engineering too early. You can still do so much stuff, right? Well, you have this is their problem now, right? You have to identify what the problem first in order to solve it. You cannot just solve something that you don't know what the problem is, right? Identify the problem. So let's say this is my problem. My reads are slow. I didn't say anything about writes is slow. It's just reads, because writing is always fast. You're writing to the end of the table, and even if you're using a B-tree data structure index, if you're using an SSD, that could be harmful for the SSD because you're rebalancing that tree sometimes if you're writing a lot, and that could cause some shifts in the disk, but still it's not that as bad as read, right? LSM is optimized for read, but writes, but that's another story. Right, so I'm reading a lot, my read is getting slower and slower and slower. It used to take 1 millisecond, now it's like 20. and now it's 100 milliseconds. What do? Table's large, what do you do with it? There's something called, most databases supports, called partitioning. And I'm going to talk about just the horizontal partitioning. So imagine this is your table, and I talk about horizontal and vertical partitioning. I'm going to reference the video here, go check it out. But in a nutshell, you have a huge table, hundreds of millions of rows. You just slice it in half. Horizontally, that's the horizontal. You slice it in the middle. And you say, this piece from this ID to this ID go to this table, right? And we're gonna call this a partition. And this ID to this ID goes to this table. I'm gonna go to partition 2. And this ID to this ID go to partition 3. So now you, instead of having one table, you have 3 different tables that represent the whole logical table. But when you query, we can find out based on something called a partition key, which usually is the primary key of the table. Doesn't have to be though. But based on that, you can know which table to hit. Now you have smaller tables, you have 10 smaller tables, and guess what? With a little bit of knowledge from the client, we can know exactly which small table or partition to hit. And now I'm working with a smaller index and my queries will be fast. Instead of having this huge index, now I have a smaller index and I know exactly what to query. So my queries are fast, just like that, by just enabling partitioning. And most databases, Postgres, for example, does that blindly for you if you enable it. And the client doesn't have even need the knowledge to know that, oh, I need to hit this table partition underscore what. No, it's just happened for you. Previously, in older releases, you had to have this knowledge. Oh, this is this table, this table, this table. Remember, guys, I'm still in the same server. It's one instance, one database instance. But with a little bit of a tweak of a feature of my database, I fixed the problem. Right? You don't need sharding. We're going to talk about sharding in a minute, what does it really mean. But you come back. You say, Hussein, no, that's not good. Because yes, my singular reads are fast. I'm selecting star from this table and yeah, it's very fast now because I partitioned and all that stuff. But my database server cannot handle, because all this TCP connection to a single server just to read stuff, it's overwhelming my server, and it's the file descriptors are blowing out of proportions and I cannot handle it anymore, right? So what do? Well, I'm not even introducing the idea of caching. You can obviously introduce a layer of Redis cache and all that stuff, but it comes with its own problems because you'll end up with inconsistency and you have to invalidate the cache and all that stuff, but you can play with that. And without introducing that extra layer, I have some tricks up my sleeve to fix that problem, right? And most of the stuff you guys know it probably, but replication, why is nobody talking about this? You have a master, backup. So, and some databases have this by default, this features where you have one master and create another server and make this server a backup of that master. And what it will do is periodically the master will push the edits, right, the writes to the replica or to the backup. So you can create as many backups as you want in multiple servers with partitions and do all that stuff. Now you segregated multiple servers, but you have one write. To do a write, you go to that dang server. You don't want to write in multiple servers. That will confuse a lot of things, and we're going to talk about it in a minute, because reading is easier than writing. Reading doesn't really cause conflicts. For writing, if I'm writing to the same row, yeah, in different servers, bad things happen. How do I reconcile these changes, right? It's just You can solve it, but it becomes a very challenging problem to solve. So you want to avoid complex problems. And how do you do it? Okay, well, I'm gonna write to my server because my writes are not as bad. I often barely write anything, but I read a lot. So you can just multiple servers. You have one master server and just push all that stuff to the replicas or the backups. And now your clients or the web servers put a reverse proxy, HA proxy, Nginx, H, anything you want, and then start funneling. Oh, you want to read? Go to this database. Oh, you know what read? You go to this backup. Go to this backup. And now you're balancing the reads. But the writes still goes to this database. That is the master. And some people will come say, "Oh no, Hussein, you don't know me because I write a lot and I need to write a lot, and my single server that does the write no longer is sufficient. It's gonna die because I write so much to it." I really doubt it first, because if you're writing a lot, you must be writing a lot to saturate a single server. I'm assuming you have a big server that does that stuff, right? But let's say you do. You're writing a lot. You still have some tricks before the final thing, which is sharding. You can do multiple replication, a two-way replication, but have two masters on different regions. In the US, this is very common. This is a US East and this is a US West. People from Florida writes to this server. Anything that has to do customers with the East, just deal with this. Anything that has to do with customer of the West, deal with this. And most of the time they don't overlap, right? Rarely. So if you have this segregation, use it to your advantage. And then synchronization of this can happen very easily because you're barely going to have any conflict. And if you do, you're going to resolve it. And if this is too complex, you finally go and do sharding, which is the following. Sharding is the idea of having a single key. See, after all of this are exhausted, right? Come down and do sharding, right? If all of this stuff are exhausted, then go do sharding. If none of them, then probably you don't have to do sharding, because sharding is the most complicating thing to accomplish. And let's talk about what. It's become easier these days, but let's talk about sharding. So, what is sharding? Sharding is the idea of splitting, like partition, like horizontal partitioning, but put the tables that are partitioned not in a different table in the same instance, same server. No, put those partitions or shards in a different server altogether. Whoa, okay. Yeah. With partitioning, you can still do transaction, by the way, guys. The database supports transactions. With sharding, with sharding, my tongue has been swallowed. With sharding, you cannot do transactions. Forget about transactions. Bye-bye. Roll back. All this beautiful commit stuff, acid, atomicity. Bye-bye. No sharding for you. You cannot do all that stuff. Because what do? If you want to write to multiple shards, this is different servers, right? And you cannot maintain the ACID transactions. I know some people don't like ACID transaction and favor the others to do with the eventual consistency, but I'm the oldest school kind of a guy. All right, so what you do is, I am about to update customer number 100. And customer number 100, you say, okay, the client, you're the client, which is your web server in this case. So, okay, customer number 100 is between 1 and 10,000. So yeah, it's server number 1. Let me establish a TCP connection with server number 1 and execute the write or the read, right? And you received another request, but this request has to do with customer number 10,017. Oh, 10,017 is between 10,000 and 20,000. And based on my sharding range, this is server 2. Establish a TCP connection to the server 2 and execute it and come back the result. And yup. You might say, yeah, I'm going to use pooling because I don't want to establish a TCP connection every time I enter. And I absolutely agree with you. You have to use pooling. You don't have to do this cold start of TCPs. Hopefully one database platform we're going to use quick and all these problems will go away. The cold start and all that stuff. But yeah, sharding is very complex. That logic that we just talked about is in your client application. That's hard, right? It's very, very hard. By the way, I made a video about sharding, guys, and actually show you how it's done. Check it out here. But what do you do, guys? Right? Do you really want to do this with your life and sacrifice rollbacks and commits and transactions and all this stuff just to do a stinking sharding? Just to do what? Scaling? You just want to scale the writes? I agree. It's beneficial. But sometimes it's an overkill. You gotta really need to think. Do you really need to shard? Right? Alright. That being said, YouTube ran into this problem. As you might think. Because YouTube is millions of videos which with billions of watch hours and hours uploaded, right? So thousands and thousands of hours are uploaded to this platform and comments and I watched listened to a podcast with the lead of YouTube talking about how they solved it. They have a MySQL database on the back end, by the way. They manage all that stuff, and the videos are, I believe, I forgot where it is, maybe S3. I might be wrong there. That was before Google acquired it and all that stuff, right? So they moved everything to YouTube, to Google infrastructure and all that stuff. But for a long time, they had a single MySQL server and they managed to do fine until the writes became absolutely disastrous. So they started doing what we talked about, and until they couldn't handle, so they had to do sharding, which is called, what we talked about is application level sharding. The application is aware of the shard, which is this piece of the partition, okay? And when you're aware, that's a problem, because you create coupling, and coupling is the worst thing you want in software, because you want software to be as isolated as possible. You want software to have social anxiety, social distancing in these days. True social distancing for software, right? Keep your software apart. They shouldn't know stuff about each other. That's just a general idea about software. Coupling is bad about software. Come back. Now, what they did is like they had this application level sharding for a long time. And it's like, okay, this is ridiculous. We cannot maintain this, because if they want to change some logic, everything breaks, right? They want to forget about resharding. The idea of resharding is like, oh, okay, I want to change the range from 10,000 because 10,000 is really low. Let's make it 100,000, right? Each shard has 100,000 rows. Oh, forget about that. Nobody can do that, because that will break every single client. You got to go to that client and yeah, so it's complicated. So they created this technology called Vitess, and I'm going to reference it here. Vitess is essentially a middleware that you send your query on top of MySQL, and I believe it's open source, right? And it's Kubernetes ready and all that jazz. And you put it on your MySQL architecture, and it's gonna do the magic sharding for you. And that is awesome, because you send a beautiful SQL query, and they parse that query and they understand what shard to hit. And you don't need anything better than that, if you absolutely need it, because nothing's for free. If you have the maintenance cost of implementing Vitess, go ahead and do it. Any technology you implement, there's a cost for it. If you're ready, go ahead, but ask yourself, do you really need it? Sometimes you do not need it. That was an awful British accent impression. Alright guys, that's it for me today. We're all learning. We're gonna learn a lot and keep learning, guys. Alright guys, and see you in the next one. Goodbye.